Mudanças Climáticas e Segurança Alimentar, palestra que será proferida pelo professor Alexander Ruane, do Instituto Goddard de Estudos Especiais da NASA, nos Estados Unidos. E para compor a mesa de abertura, gostaria de convidar o professor Márcio de Castro Silva Filho, diretor científico da FAPESP. O nosso conferencista, professor Alexander Ruane, do Instituto Goddard de Estudos Especiais da NASA. Representando a comissão organizadora das conferências e escolas FAPESP 2024, professor Carlos Alfredo Joly, da Unicamp. E o nosso debatedor, professor Jurandir Zulo Júnior, também da Unicamp, a quem agradecemos a presença. Gostaria de lembrar que temos tradução simultânea. Quem precisar de fones, por favor, se dirija à recepção do evento e mandar uma saudação aos que assistem essa gravação no canal da agência FAPESP do YouTube. Então, passamos a palavra para a abertura ao professor Márcio de Castro, nosso diretor científico. Só colocar a sua apresentação aqui.
Muito bom dia a todas e todos. Queria dar as boas-vindas à FAPESP e cumprimentar os colegas dessa mesa de abertura, em especial o nosso palestrante, o professor Alexander Ruane, mas também o colega Carlos Alfredo Joly, representante da comissão organizadora dos seminários, e também o professor Jurandir Zulo Júnior, que participará como moderador dessa atividade. Eu vou rapidamente fazer uma divulgação de alguns dados que poderão ilustrar um pouco sobre o tema das mudanças climáticas e segurança alimentar. Esses dados mostram a prevalência de segurança alimentar e insegurança leve, moderada e extrema, de acordo com o PNAD, ao longo dessa série histórica de 20 anos, mostrando aqui um grau de significância com relação a uma porcentagem da nossa população que ainda precisa de uma atenção especial em termos de segurança alimentar. No estado, na região sudeste, em particular, o estado de São Paulo, nós temos praticamente 20% da nossa população que tem algum nível de insegurança alimentar, sendo que 3% insegurança alimentar grave. Apesar de que o Brasil é uma potência na agricultura tropical e sendo o terceiro maior exportador do mundo, atrás dos Estados Unidos e da China, mas apesar disso, dessa grande produção de alimentos listados aqui, suco de laranja, soja, carne de bife, frango, milho, porco, nós ainda temos uma parte da população que não tem acesso a essa fartura na produção de alimentos. Nós fizemos um levantamento com relação ao investimento da FAPESP em duas áreas que estão correlacionadas e que são objeto desse seminário de hoje, com relação a um programa que a FAPESP tem em mudanças climáticas, que já foram aprovados mais de 400 projetos de pesquisa, e na área de segurança alimentar também, mais de 95 propostas apoiadas pela FAPESP ao longo aí de uma janela de cerca de 20 anos. Né? E eu queria trazer para vocês que a diretoria científica está trabalhando na construção de um novo programa aliado às várias iniciativas que a FAPESP tem na área de bioenergia, o programa Biota ligado à biodiversidade, Mudanças Climáticas, Políticas Públicas, o Programa PROASA, de pesquisa no Atlântico Sul e Antártica, de forma a integrar as diferentes iniciativas num programa multidisciplinar, com a participação do governo e financiando, então, projetos temáticos e jovens pesquisadores. Esse é o nosso desafio próximo, de fazer com que, na expectativa até o final do ano, ou início do ano que vem, a gente possa entrar nessa aliança global, inclusive com a participação de agências no exterior. Tendo dito isso, eu já passo a palavra ao professor Carlos Joly para a sua fala. Muito obrigado.
Bom dia a todos e a todas. Agradeço a presença do Dr. Márcio, diretor científico, do Dr. Alex Ruane, do nosso palestrante, o professor Ruane, também da professora Estela Burger, que é membro da comissão que organiza essas palestras. Quero já aproveitar no início para falar sobre as próximas palestras que nós temos. Já temos a programação fechada até novembro, e a próxima palestra vai ser Repensando a Pós-Memória, depois do 7 de outubro. Depois nós teremos uma de latim em pó, vai ser, com certeza, bastante polêmica, e a questão dos combustíveis e a mobilidade no Brasil. Então, essas são as nossas próximas palestras. Bom, eu gostaria de apresentar o Dr. Jurandir Zulo Júnior, que será o mediador desta mesa. O Jurandir é uma daquelas pessoas que não se contentou em fazer uma graduação. Ele se formou em matemática e depois ele entrou e cursou engenharia agrícola na Unicamp, fez seu mestrado e fez seu doutorado lá. Hoje ele trabalha no Centro de Pesquisa Meteorológicas e Climáticas Aplicadas à Agricultura, o CEPAGRE, que é um dos centros mais ativos do ponto de vista de pesquisa na universidade. Ele foi o coordenador dos Centros e Núcleos Interdisciplinares da Unicamp, que reúne todos os centros e núcleos da universidade. Ele faz parte de um conjunto de organizações internacionais, como membro sênior, tem uma participação bastante ativa. E, além disso, ele é meu colega como professor no doutorado interdisciplinar em Ambiente e Sociedade, que é sediado no IFCH, no Instituto de Filosofia, Ciências e Humanas da Unicamp, juntamente com o Núcleo de Pesquisas Ambientais do NEPAM. Então, Jurandir, você que conhece bem o trabalho do Dr. Ruane, vai nos conduzir por essa palestra. Muito obrigado.
Bom dia a todos.
Som, teste.
Agência de vínculo do professor. Também parabenizar a FAPESP pela iniciativa, né? Muito importante esse contato com os pesquisadores. Também saudar todos que estão presentes aqui. Acho que é uma oportunidade muito grande de ter contato com um pesquisador como o professor Alexander. Ele já trabalha em conjunto aqui com grupos do Brasil já há vários anos, né? Ele vai mostrar um pouco aqui o trabalho dele. Também tem uma atuação importante no IPCC, trabalha muito com modelagem, com agricultura, com segurança alimentar. Então, é uma oportunidade muito, muito boa, né? Nesse momento que nós já estamos aí com uma discussão muito grande de mudanças climáticas ou até emergência climática. Nós tivemos agora essa semana 2 dias muito intensos de trabalhos na Unicamp, aqui do Programa de Mudanças Climáticas da FAPESP. Eu vi que tem algumas pessoas que participaram, né? Tiveram oportunidade. É um programa já que tem 16 anos, então a FAPESP também tem financiado bastante. Quero agradecer também ao professor Ciro, que seria o mediador, mas por motivo de saúde não pôde participar, então agradeço a todos, professor Zac, professor Márcio, professor Jolie, que foi meu professor na graduação. E não sei quem teve a oportunidade ontem de assistir o Jornal Nacional, né, teve uma reportagem sobre a questão de segurança alimentar, né, mostrando como estão os países, né? Então mostrou a questão do Mediterrâneo, a produção de azeite, que está caríssimo, né? Quem vai no supermercado tem notado isso, problemas na Grécia, na Itália, na Espanha, no México, no Brasil. Então realmente é um assunto de grande relevância, né? E a estimativa que a ONU fez, né, a FAO fez, foram perdidos em 30 anos 3,8 trilhões de dólares. Isso em reais são 21 trilhões de reais. Né? É mais ou menos, uns 60%, fiz uma conta rápida, assim, dá uns 60% de perdas da nossa produção aqui no Brasil. Então, é como se nós perdêssemos todo ano 60% da nossa produção, que, como o professor mostrou, o professor Márcio, é importantíssima para nós e também para o mundo, que o Brasil é um grande exportador de alimentos. Então, realmente são dados impressionantes. Tivemos, na semana passada, né, as queimadas, teremos agora uma outra onda de calor. Então, o tema que será tratado aqui pelo professor Ruane, sem dúvida, né, está bem atualizado e toda a experiência dele, sem dúvida, será muito importante. Então, quem está aqui presente, né, aproveite a oportunidade. Nós teremos depois uma sessão de perguntas, né, certo? Então, quero agradecer novamente e acho que eu já passo para ele. Então, passo a palavra aqui para o professor para que ele faça a apresentação. Muito obrigado.
Obrigado. Thank you. Hello, everybody. I have to speak in English. I apologize. But I am very grateful to be here and very much appreciate the invitation from FAPESP to come on down and talk about these important issues. Let me make sure this is coming up. So once again, my name is Alex Ruane. I am the co-director of the Climate Impacts Group at the NASA Goddard Institute for Space Studies, which is located in New York City. I am going to explain all of the other acronyms you see on the top of the screen. I'll talk about AgMIP, which is an agricultural modeling activity, and the IPCC, which is trying to understand climate change. But the goal of my talk today is to help understand how we are approaching climate change and food security, understanding the role of models and assessments, not just for their scientific importance, but because they are helping us develop plans for the future, develop solutions that will allow us to have a more resilient society and a productive future. So coming from NASA, I have to start by showing what you might think of when you think of NASA. This is my all-time favorite space image taken by the Voyager satellite probe, which went out past Saturn and is now taking a picture back at the sun, which is behind the planet. And it's just the most glorious picture. And it's made even more amazing by knowing that those little dots you see there are the other planets. So the Earth and the Moon actually show up in the far distance. And it's this amazing perspective on the universe and our solar system and our place. This is one of the things that NASA does, is we try to inspire and help people see the context of our lives. Now, of course, NASA does not just look out to space. We also look back at our home planet, and we look at what is happening on our home planet. For example, here in Bolivia, or there in Bolivia, you can see how agriculture and forestry and ecosystems are interacting. So now, too fast, let's see. Let's see, that animation does not seem to be working. That's too bad. This worked a moment ago. Let me just try one quick fix and see if I can make it work. that's better. And somebody's helping me. There we go. I don't know who helped me, but thank you. So this is an image of NASA's Earth Science satellite fleet, which is looking down at the planet. You can see in the bottom left the minutes ticking just a couple days ago. This is where all the satellites moved, and you can see they're moving very quickly, flying around the planet, taking imagery in all different wavelengths to understand what's happening on our home planet. It's a very impressive set of satellites. So my job is to take that information and our models and make sense of it and understand how it will help society. So I co-direct this climate impacts group. We focus on agriculture, we focus on cities, this is New York City, and we focus on ecosystems. And I'm going to be spending almost all of today talking about the agricultural side on the left. So to preface everything that we're doing, it's really important to recognize that the world is asking a lot of the agricultural sector. The agricultural sector is really taking on 4 challenges all at once. We have to sustainably increase production so that we can provide healthy food for growing and developing populations, which are demanding more food and healthier food. At the same time, we also have to adapt to climate change and ongoing climate extremes, as we just learned about the fires and the floods several months ago and other things that are affecting just this region. We also have to mitigate emissions from agricultural lands, which historically have been somewhere between 1/4 and 1/3 of total greenhouse gas emissions. And then we have to recognize that none of this will happen if we cannot maintain the financial incentive for farmers to live what is in many cases a very difficult life, waking up early, working hard, and playing with very high levels of risk to their livelihoods. So every one of these challenges is very substantial. And when you put all 4 of them together, you realize why this is such a tricky problem. So today I will be talking about the urgency of climate change, how we are using agricultural models to prepare for the future, and how we can empower successful climate action. So let's start with this climate change urgency. And I'm going to start by showing this image, which I took from a projection this morning, showing the world today as the anomaly of the surface temperature, 2-meter temperature. And I show this image just to point out a couple things. You might see that there is both blue areas representing slightly cooler than normal and some orange areas representing warmer than normal. This is just for August 30th. And it's often hard to remember what August 30th should feel like. We don't really remember exactly what, especially the transition season, should feel like. But this map shows you that here in Sao Paulo, it's kind of an average day, maybe a little warm, right? There's a little bit of orange. This is not quite showing up. But you can see that there's some blues, some oranges, but if you look, the orange areas are deeper than the blue areas. The warmer areas are overwhelming the cooler areas. And if you ignore all of the crazy storms happening over Antarctica, there is a picture here of generally warm conditions because the world is warming. But those cool and warm events that are the difference between 2 days ago and today, that's weather, that's the climate variability. That's not going away. We are just moving towards a climate change world, and you can see the shift even in these daily maps. But it's important to recognize that climate variability is different than climate change, but they are related, and I'll talk more about that. So I was a participant in something called the Intergovernmental Panel on Climate Change, or the IPCC. This is a body that was created by the UN Framework Convention on Climate Change to assess the literature of the climate science field. So effectively, the people who were negotiating mitigation treaties like the Kyoto Protocol or the Paris Agreement, they needed the scientific information. They asked the scientific community, and the scientific community has performed a series of assessments. The last assessment report was the 6th assessment report, and it resulted in all of the documents that you see here, which together had more than 800 authors, assessed more than 100,000 publications, and dealt with 300,000 review comments. So if there are scientists in the room who know about submitting a paper and getting some review comments back, there were 300,000 review comments that we had to deal with, one by one. But luckily we had a big author team to deal with it. All of those thousands of pages of reports were boiled down in something called the synthesis report, which tried to take all of climate science and bring it down to 10 pages and 7 figures. So I was involved, I was one of the lead authors in the physical science basis report on the left, and then also in the synthesis report. And the figure that before I do that, this is the picture of that group that put together the synthesis report. And I challenged my wife to find me in this figure, and she couldn't do it the first time. And the reason is because I'm up there third from the left, and I look very short in this picture because I wasn't actually there. Instead, I was here talking with some delegates trying to negotiate a figure when they were taking the picture, and I missed it. So this is actually what it looks like in those meetings. We have a delegate from Ireland, a delegate from Kenya. You could ignore the nameplates, those were something else. And then I was up there speaking with another scientist colleague about what were the challenges in accepting and understanding the figure that we were presenting. And the figure that we were presenting was this one, which is just one part of a larger figure, but it is a representation of how climate has affected the world since 1900. And instead of showing a line plot, which is a little boring, we have represented each year as this climate stripe. And you may have seen these. Each stripe represents the global temperature change anomaly compared to a pre-industrial period from 1850 to 1900. At the beginning of the century, you might see that there's some blue stripes and some tan stripes. But as the years go forward, you can see that it becomes orange and then it becomes red. And this is the telltale sign of climate change that has affected the planet in the last 120 years because of industrial activity and other greenhouse gas burning. Now, we have seen impacts of climate change just in this past year, and the assessment report shows how it's affected extreme events, how it's affected all different sectors of nature and society. But when we look to the future, we don't know exactly what will happen because it depends on the decisions that we make. So each of these rows here represent different levels of greenhouse gas emissions. The top row is if we have very high emissions, and you see that this gets into entirely new colors, deep reds, that by the end of this century could be affecting the world, up 4 degrees global temperature. Just as a reference point, the last ice age was 4 degrees cooler than pre-industrial. So 4 degrees warmer is like the opposite of an ice age, very dramatic global impacts. You can see that if we are able to limit our emissions, we can keep it to a more steady level, but even in the lowest emission scenario kind of imaginable, it is still reaching warming levels that we have not seen in a long time. That one is designed to cap out at about 1.5 degrees. And if you've been following the literature, you'll know that since 2020, when this graph switches from the past to the future, we've actually had years that have almost approached 1.5 degrees already. Now, what I really liked about this figure was that this is a nice science figure, but it's not necessarily relatable until we put the bottom on it. And this is a representation of how different generations have experienced climate change. And you'll note that people who were born in 1950 have a very different experience than people born in 1980 and those born in 2020. And their experiences are different in several ways. One, the actual amount of warming that somebody born in 1950 experienced was not very large until the last 20 or 30 years of their life when it has accelerated dramatically. Somebody born in 1980 has seen that acceleration almost throughout their lives. But that baby born in 2020 has a huge uncertainty in their future in a way that that person born in 1950 doesn't. And that is both a relationship to the past, but an uncertain future that also needs to be recognized. So we really loved that this figure got a lot of press attention. It went on Twitter and Instagram and TikTok and all kinds of things that got passed around. So one of the things that's very exciting is we made a new tool that you can try out called NASA Climate Legacies that allows you to make your own plot like this. So this is my family. This is my father and me and my son. And we've put ourselves into this plot. And you might notice that for Alex here in the middle, you see me playing baseball when I was a kid. My parents would recognize me in this picture because that's what I was doing around that age. My son above, you can guess what sport he plays. He's a football soccer player. So you can customize this and put your own images for everybody in your family, every step along the way. It's very fun for me to guess what I'll be doing when I'm 80 years old, but you can try it out. And not only can you do this, you can turn it into a secondary image. Same thing, I have a t-shirt that I wear around New York and starts many conversations. All right, so within that IPCC, one of the things that we really were trying to do was turn the big question of climate change into something more tangible, something that actually allows you to take action. And one of the first things we did was we defined this new term called a climatic impact driver, which is a specific climate condition that directly affects elements of society or ecosystems. So instead of speaking generically, we wanted to think about the specific elements that lead to positive or negative changes, or even sometimes inconsequential. But these are specific categories of climate conditions that we need to be understanding and preparing for. And many of them make a lot of sense when you look here. So we have to understand how the average or mean surface temperature is changing. But we also have to understand how extreme heat is changing. And they're both temperature, but they have very different effects on the way we plan our society. We might choose a crop based on the average temperature, but we might choose a variety or a seed based on its tolerance to extreme heat. So we have to be able to understand that they have different climate physics, but also different adaptation priorities. And you could go across this whole list. You can see that we have those related to temperature. We have those related to rainfall and drought. We have wind and storms, snow, other things like radiation and chemistry, coastal effects, and open ocean effects. And you'll note in here we have, let's see if I can find it, this isn't working, but at the very edge of the wet and dry, you'll see fire weather is one of the conditions that we wanted to understand. So the general idea is we are encouraging everybody to look at their region in terms of how each of these things are changing. So in our assessment report, we noted that several of these things really are changing, and they are changing in ways that we can measure. So on the left is a representation of extreme heat events. And what we've done is we looked back to the pre-industrial condition, 1850 to 1900, and we found the event that happens on average once every 50 years. So that very extreme event that you might see once or twice in your lifetime. Today, around 2020, when this chart was made, that event is now happening almost 5 times every 50 years. So instead of 1 out of 50 years, it's now more like 1 out of 10 years. When we go into the future at 1.5 and 2 and even 4 degrees out in that deep red part of the climate stripes, out there it is happening 4 out of every 5 years. So 39 out of 50 years, you would expect that extreme event to occur. Another thing we can do is we can ask ourselves, well, what will the new 1 in 50 year event look like? And that's what's shown at the bottom. The new 1 in 50 year event will actually be 5.3 degrees warmer. Even though the world is only warmed 4 degrees, the extreme event has warmed by 5 degrees. So this is a demonstration that the extreme events are actually changing faster than the average. And we could do the same thing on the right for heavy precipitation related to things like river floods. And you can see a similar story where the 1 in 10 year event can occur up to 2.7 out of every 10 years out in that future. So we see these projections, we see the changes already occurring. We made projections and assessed the literature for Brazil as part of our South America and Central America chapter. And I've pulled just the regions that overlap with Brazil here. And you can see in blue colors are these climatic impact drivers that we have assessed to be increasing with climate change. So you can see that that means average temperature and extreme heat are both increasing. Cold spells are decreasing. That's the other side of the equation. And if you go out, for example, in northern South America, up in the northern part, you'll also see that there is, in that place, a decrease in rainfall, increase in flooding, increase in certain types of drought, and an increase in fire weather. And also all kinds of coastal flooding and other changes. And you could look at this table. I won't read all the way through, but this table provides a beginning basis of how climate change is affecting Brazil. And you'll note that in many places there is a white color, which means we could not see a clear indication in the literature for the direction of change. It does not mean no change. It means that there is not a clear scientific basis for a confident projection. One of the other things, of course, we want to do is recognize what are those actual response thresholds. At what temperature and humidity level, for example, does the body struggle to maintain its heat and start to overheat and become a health concern? So here is a metric that is a combination of heat and humidity, and we've looked out under a high emissions pathway, and in the middle of the century you can see a dramatic increase in the number of these extreme heat days. Now, I know that there's been some talk in the media that this means that areas that are deep red are uninhabitable. That's not actually what is meant by this chart. What is meant by this chart is to say that you will be seeing in the middle parts of the day, in the hottest part of the day, conditions that make it dangerous for outdoor construction, outdoor agricultural labor, and things like that. And that will need adaptation, either through different types of labor practices or water breaks, or maybe working in different times of day. How exactly that adaptation occurs, I'm not sure, but the challenge is there for us to meet. What's good to know is that there are parts of the world that are very hot and humid, and people still thrive there. So we need to learn from those places and prepare in our own. Another thing that I just want to lead here with is this general idea that risk is more than just a climate extreme, more than just a climate hazard. These climatic impact drivers lead to hazards, but risk only occurs when those hazards affect something that is vulnerable. So if a heat wave affects a crop and the crop is not tolerant, that is a vulnerable crop. If it also, for risk to occur, there has to be an exposure, which means the heat wave is occurring in a place where there are crops, as opposed to a place where there are no crops. So exposure means there are things that are in the path of this extreme event. Vulnerability means that those things can be affected by that extreme event. And then the final thing at the bottom is response risk, which is if we try to adapt in a way that actually makes that problem worse or makes a new problem, then we might change the risk in that way. So we have to think about our planning with these things in mind. And one way to think about that is if we are mitigating our greenhouse gases, if we are reducing our greenhouse gases, we are effectively reducing the hazard that we are facing. When we adapt, we're attacking this side by saying that we are going to reduce the vulnerability, perhaps through a more heat-tolerant seed, or we are shifting the exposure, perhaps by making sure that those workers are not in the fields working in the hottest time of the day. And then when we're thinking about response, it's really important that we coordinate across systems so that we understand how our response actions affect vulnerable populations and may have side effects on other parts of the economy or our cultures. So this is why we need to think about climate change not just as a physical science, but as a sectoral issue. And here are just some pictures that I've taken through my travels of different sectors: coastal, cities, fisheries, agriculture, ecosystems, and human settlements all have very different challenges and things that we need to plan on. All right, so let's get to agriculture. That's why we're here. Agricultural models are something that we can use to prepare for the future. So as we're thinking about these food security issues, it's important to recognize that the cereal production around the world has been going up over time, that there is more and more agricultural production every single year, but the population has also been going up. And if you look first at that line with the triangles, that shows that yield is going up, but the line with the circles shows that we actually have been, in recent decades, decreasing the amount of food per person in the world. So that suggests that the population is growing faster than our food systems can keep up with. It's also really important to recognize that something like maize or corn is a global commodity. It's grown all around the world, but a huge amount of the prices and the international trade and the production comes from just a few small regions. On the right here is 90% of maize production in the world, only from those few pixels. You'll see the Midwest United States, a little bit of Brazil, parts of Southern Europe, and parts of China really dominate the global picture. So it's important to recognize that we have to look at the international trade, but we also can't forget these smaller maize-producing regions just because they are not internationally traded. In many places, these are critical for local food security. So when we're talking about a crop model, we are looking at something that is representing the fundamental features of an agricultural field. We are looking at the soils, the plant, both above ground, the roots. I like to say the roots, the shoots, and the fruits. All of those different parts of the plant. And there's complex physical and biophysical relationships and equations that are represented within this crop model. And all kinds of other things I won't get into. I can get distracted by this figure because there's so much going on. But fundamentally, we're trying to understand how a field is responding to the genetics of the plant, the environment that it's in, both the soils and the weather, and then the management of that field by the farmers. So we started this project called AgMIP, the Agricultural Model Intercomparison and Improvement Project, back in 2010 with the fundamental idea that we have to link for food systems. It can't just be crops, it has to be crop and livestock models. And in many cases, there are mixed systems, but also that farmers don't really act only on yield. They act on net economic returns of their fields. So we have to connect the crop and the livestock models with the agricultural economic models. And together this becomes kind of a super system of agricultural models that include all of these elements. And once we configure these models, we can run historical information through, such as historical weather data and historical policy. As we loop through this system here, we can evaluate how well our models do, and we can calibrate and improve those models. Once we use that process to gain faith in our models, we can go to the more interesting track, which is looking at alternative systems. It could be alternative climate, could be alternative adaptation and policies. We drive those through our agricultural models. We get projections of future production and trade and food security. And then also we can loop through and try out different adaptation and mitigation or extensions into things like water resources and cultural change. So AgMIP is founded on that simple graph that I just showed there of calibrating and then using models to explore different systems. And we've been going now for almost 15 years. And this was our recent global workshop in New York City. And the general idea is we are transdisciplinary with climate, with crops, with livestock, with nutrition, with economics. Those are all the pieces we need to understand the food system. So we have tried to bring them all together. They're all waving hats in this figure. The ones who are waving golden hats, those are the economists. The ones who are waving sky blue hats, those are the climate scientists. The green hats are the agronomists, and you could try to decipher the other ones. There's somebody in the front waving an orange hat. That's nutrition, supposed to be like a sweet potato. That's how we figure it out. All right, so AgMIP has developed more than 50 different activities. As science coordinator, I track all of these and try to help develop the science protocols and make sure that they can interact and learn from each other. So of course we're here and there's been a lot of work in Latin America and the Caribbean. I'll talk a little bit more about that soon. But I'm also just wanted to highlight a few more of these. We are working on an experimental level with field data to understand in particular right now how evapotranspiration is happening in soy fields. We have a new project called AgML, which is using machine learning and artificial intelligence to add on to our crop models and to form new crop models. We are working at the interface of adaptation and mitigation so that these are not considered separate things, but things that could actually come together, for example, in a system of rice intensification as one proposal there. And then we are taking all of this information into national assessments that are informing policy and adaptation and development priorities. And there's many, many more things on here that you can look at. And I would love to follow up with people about that. So you can check out our website and get on our listserv if you want to learn more about AgMIP. Now, AgMIP was founded, I was a postdoc at the time working with Cynthia Rosenzweig, and the two of us kind of got this all going. Cynthia has had an amazing career which was recently recognized with the World Food Prize, which is like a Nobel Prize for food systems. And the prize specifically called out AgMIP as one of Cynthia's primary contributions. So we're very proud of Cynthia and all that she does. I was saying just before I came up here that AgMIP had its kickoff meeting in California in 2010, and Eduardo Assad from Embrapa was on our steering group and immediately said, I love it and I want you to come to Brazil. So we were in Campinas only about 6 or 8 months later. Here's that workshop photo, and you might find some people that you recognize in here. We've had several meetings in Campinas. We've been in Peru several times, Colombia. We had a global workshop in Costa Rica. So we really do want to work in this area. You'll see people in this photo also from Argentina, from Uruguay, from a bunch of other places that have all come together to work on these issues, and from many Embrapa groups all around the country as well. And then, of course, coming down here, we have collaborators at University of Sao Paulo, Unicamp, Embrapa, and Passo Fundo, and Piracicaba, and other places as well. So what does AgMIP do? Fundamentally, we are trying to make crop models and other agricultural models that respond to all of these different things that can make a good crop or a bad crop. So we want to understand temperature extremes from cold to hot, rainfall extremes from drought to flood. We want to understand extreme storms, pests and diseases, air pollution, and that orange plus in the middle is all of those other climatic impact drivers, which I couldn't squeeze in here. Now, if we can make crop models that respond to these things, we can monitor in the real time. So we can look from satellites, we can look in field data, we can run our crop models. Then we can also forecast into the future. But of course, we can learn from these crop models in many additional ways. So first thing we can do is look backwards and understand over the last 30 or 40 years, how can our crop models tell us what really happened beyond what we observed in the field? So we can detect and attribute and say that there was a good year because of this condition or a bad year because of a drought. We can also go back and do what is called counterfactual management and say, could we have gotten a better result if we had planted a different seed? Or if we had used a different planting date, would we have had a better result? So this helps us understand what is happening. And then, of course, we want to go into the future, but if we go far enough in the future, we're no longer making a prediction or a forecast. We are making a projection because it's contingent on so many different things that are changing. So we've already talked about how climate is changing out into the future, but we also know that there are shifts in markets, changes in policies, changes in socioeconomic conditions, and larger questions of environmental sustainability, whether it is soil degradation or runoff pollution or other things like that. By the time we get out here, it depends very much on the decisions that we make and the policies that we are choosing, and the shape of what future agricultural systems will look like. But here it's very, very important that we look this far out into the future because the adaptations that we are asking for are requiring longer term investment. They are not something that are ready today, but we can be proactive. We can start to think about what will be needed in 5 years, in 10 years, in 20 years. And in some cases, it takes that long for us to develop a new seed or to build a new reservoir, and we need to start preparing soon. So those projections of the future are what I'll show here, and this is a movie, and it seems to be working. On the bottom left, you see the maize yield projections, and on the upper right are wheat yield projections. And this is from an ensemble of 11 different crop models run with 5 different climate projections. And you can already see that the maize yield is turning more orange and red. This means the yields are decreasing because of climate influences. The wheat yields, you'll notice, have some green in them because carbon dioxide has a particularly strong effect on wheat as a C3 crop. The biophysical structure of wheat in photosynthesis actually makes it benefit more from carbon dioxide. You'll also note that wheat is often grown in cool seasons and in cool regions. Let's see if I can get it to come back. Give me 1 second. It's okay here. Good. Thank you. Hold on. Okay, I'm not sure I'm going to wait for the whole video to go through, but again, you can see how the wheat yield in the cool seasons and cool regions, you do see some greens, but I'll also note that there are places that are not green, even for wheat. So parts of southern Canada, Mexico, East Africa, and the Punjab region of India and Pakistan are all places where even wheat can see some declines. Now, when we look at these models, those projections that I just showed, I should have said very clearly, are without adaptation. So these are situations where farmers are watching the yields get worse and they do nothing. I don't think that's what will actually happen. I think farmers will see that the climate conditions are getting worse and they will respond and we can help them. That's what wakes me up in the morning, is the ability to give that information to those farmers so they can begin to plan. It is important to note that there are limits to the adaptation. This is not something that we can just keep moving the genetics, keep moving the irrigation, and everything will fix itself. We did one study where we asked ourselves, in a future condition when it gets warmer, if we want to keep the same growing seasons, can we find seeds anywhere in the world that will match that requirement for heat over this long growing season? And oftentimes people think about just the average temperature change or the average temperature of a region. But one of the things that makes some of the mid-latitudes, places like Brazil and the United States, very good for agriculture is that there are long growing seasons. And over that long growing season, that warmer temperature accumulates and gets stronger and stronger in its effect. So here what we're looking at, places where you see red and dark red are places where there are very few seeds that can keep, that can allow a plant to grow over this long growing season. So one of the things that you see often in climate change is the warmer temperatures cause the plant to accelerate its maturity through the growing season. So effectively it is ready to harvest before it has soaked up enough sunlight and therefore is not as productive as it would have been if it could have stayed in the field longer. So these oranges are places where we are concerned that we need to develop new genetic material to adapt in the future. Another thing that we want to look at is food shocks. So this is extreme events in the food systems. And I would love to tell you that there was a very simple pathway between a hazard like a drought, which affects agricultural production, which affects trade from the farm gate to export, global markets, back to regional markets and households and health. If it was this nice clear pathway, things would be much easier to model, but it's not. First, because government can often interfere or cause constraints on this system. And then the other thing, of course, is they're all interconnected. And we know this because when COVID appeared out of the health sector, it very quickly spread throughout food systems. And we know this because climate change is coming out of this corner and has spread throughout the food systems. And we know this because Ukraine came out of that corner and very quickly spread throughout food systems. So we have to be able to track these things. And I would say right now, we have pretty good models in the green area, some models in the blue area, but the red area is quite uncertain. And people generally don't like to model governance and politics because it's very messy. So if we want to be able to predict food insecurity on an acute level, on a sharp level, then we have to be able to fill in this chart more. The other thing to note is that systems, but also people, act differently under stress. And some of the things that we assume will be rational, calm decisions may not be when there is a real crisis on hand. So bringing back the same list of climatic impact drivers all along the top here, we can actually ask which systems are directly affected by these. So we made a table in the IPCC for crop systems, which was just one row in a much larger table. All of these areas with dark red are places that we know crop systems respond to. So we know they respond strongly to extreme heat. They respond strongly to things like total rainfall and river floods, but they don't really respond to things like the acidity of the open ocean, right? So we might be able to ignore that one. But cropping systems was one of the most strongly climate dependent systems that we looked at anywhere in all of nature and society. So it's very important that we track all of these things. However, when we look at our crop models, we can classify them this way. And I know there's a lot on this chart, but green stars are things where we think the crop models do pretty well. We capture the effect of average temperature and total rainfall pretty well. The light blue stars are places where we capture some of the response, but think we can do better. And the blue ones, the dark blue ones, might be something where we can add an additional model. So for example, if there's coastal flooding and sea level rise, we might have not a crop model to tell us about sea level rise, but we can link those results in and make something to do with it. But you'll notice there's too much blue and even some empty squares here because we need to improve our crop models. That's why we always talk about agricultural model improvement. And there are many places here. The red dots show some of them. I was just having a discussion earlier about sequential extremes, how a flood or a drought early in the season might make you susceptible to a damage later. This is something that we think about a lot. All right, so with all of these models telling us that things are changing and we have to prepare, well, what can we actually do about them? So the first thing to note is that coming from NASA is a really nice place to be because we have so many different perspectives on a farmer's field. We can understand the weather data like rainfall. We can look down from our satellites and look at the plant itself and understand the health of the vegetation. We can use satellites to penetrate the top layer of the soil to tell us about soil moisture and other characteristics. But those really still give us a small view, and the crop models get us all the way to the bottom of the plant and some of the biophysical processes within. But when we take all of these things together, we can get very interesting perspectives on what is happening. So we also have very, very powerful computers. And this is a map of the US state of Iowa. And I'm gonna press a button to make the animation go. And what you're seeing here are supercomputer simulations using crop models. And we have run this whole state at 30-meter resolution. And we're going year by year with yellow being corn or maize and green being soybean. And the brighter the color is, the higher the yield was that year. And in the United States, we had a very bad drought in 2012. So you can see in a second, it will get dark right there. These simulations help us understand what is actually occurring within the fields. And when I say within the fields, you're going to zoom in all the way until you can see the elevation changes and the soil characteristics that make even within field variation something that farmers are aware of. Now, I've shown this exact chart to Iowa farmers who walk right up to it and say, is that my field? Like, where am I on this chart? Now, I'm going to go to the beginning again, and this is what hopefully won't work. Now, before I press the animation, you might look at this and realize that there are some non-physical things in this chart. The line that goes across the middle with the little kink, that's because we're data limited. We don't actually have true information about planting dates, and we made an assumption based on counties, and you see that edge. So as a scientist, I know the weaknesses of this, but the computer power allows us to do really amazing things. And now we need to work with the farmers to actually configure. So that's what we're doing. We actually have a project with the Iowa Corn Growers Association where we are aligning satellites with ground observations, which is now coming directly from the combines and the tractors. They are pulling data directly from the field. Then we also have weather information, and we have our crop models. So we need to link all of these things together. And then I somehow lost the tag, but the purple one is supposed to be machine learning. Sorry. And machine learning and artificial intelligence can help us pull these pieces together so that we can understand for each part of Iowa what is the best combination of our observations to understand what's happening. So when we're thinking about adaptations, there is a nice chart that was put together by Mark Howden from Australia. And on the x-axis, you can see climate change getting stronger as you move to the right. And on the y-axis is the benefit of a given adaptation. And when we have just a little bit of climate change, there are adaptations that we can implement almost right away. Farmers have the ability to select a different variety or a different planting time or a row spacing. Many of these things have an initial benefit as the climate changes, but you can see that line levels off. And that means that as the climate change continues, you're no longer getting a benefit from that adaptation. So at a certain point, you have to go to a next level of adaptation, which might be shifting your production chain. It might be inventing new types of germplasm, new types of seeds, or diversifying your farm and managing risk in a different way. Even that levels off, and you might need an even more transformational change, including things like land use changes or thinking about new ecosystem service products on your farm. Now you'll notice that in each of these cases, the leveling off is where you start to be losing. That's where you are trying to adapt and can't do it anymore. So if we can provide information and be proactive about planning, we can stay on the up longer and longer and longer and stay right on the edge of maximum benefit as the climate change occurs. That's what we would like to do, is provide that information so the adaptations are able to be implemented. What I don't think is very well known is how many bad years can a farmer take before they are forced into action. And that type of socio-cultural, economic, and kind of behavioral understanding is something that we need to push forward. Now, the good news is the agricultural and food system is very complex. And that might sound like a weird thing to say. The good news is it's complex. But what I mean by that is there are many different places that we can find leverage and improve food systems to make them more resilient. So here is just a diagram of food systems, and you'll notice, hey, I can use my cursor here. The biological system on the left, the kind of weather that comes on the top, economic system, political system, social systems, health systems, these things all interact. But in each of these areas, there are ways for us to improve resilience. The other thing that's important to note is that there are many time and space scales on which we can act. And I know there's a lot going on in this chart. I'd encourage you to look up this paper, Stewart et al. 2024. I'm a co-author there as well. What we've done in this chart is taken a very classical weather diagram that shows that there are time scales and spatial scales to atmospheric phenomena. So let me try to make that easy to understand. There are things in the atmosphere like turbulence, which are very small and very fast. On the other side are very big and slow things like climate change. And there's many things in between, like thunderstorms are here and hurricanes are here. El Nino is up here. So we can understand how each phenomenon has a time and a space associated with it. But what hasn't been done is mapping these into the agricultural sector and understanding that farmers really have a concern about what they're doing today, what they might do next week, and what type of farm they might leave to their children and their grandchildren. So they have a very wide interest area. Consumers might not really be thinking far out into the future, so they kind of end around a month or two. The aid agencies have a different group that is focusing on disaster relief versus on developmental aid. And then you can go down this chart and realize that there are groups like reservoir construction and emissions policymakers that are mostly concerned with the long term. So we need to be speaking to the right people about the type of information that is needed. And we could do the same thing for space and the way they interact. So as we're looking to address climate change and food security, there is this concern that the problem is too big, but we don't need to solve it with one solution. You may know the legend of a werewolf, which can be killed only with a silver bullet. This is not really what we're looking at. We're looking at trying to figure out many different ways to attack this problem. One thing we can do is we can change our diets and reduce the demand for food. We can fill the production gap and intensify farms or make them more efficient. And then, of course, we can also reduce food waste and food loss. And each of these are major categories that will get us there. There's many additional proposals of things that have been suggested. And these cover those same ideas of reducing demand and filling production and sustaining productivity. But one of the ones that's in here is this climate change mitigation, which is if we don't even have as much climate change, we don't need as much adaptation. It's kind of the easiest global solution, is just let's not get to those deep red stripes in the first place. So right now, we really are facing two choices. We can take the best strategies that we have right now and mitigate and adapt and implement those right away. The other thing that we can do is we can create better conditions for future action. And I don't mean this to say that we push the problem down the road, but in some cases, we actually have to create the condition for us to be successful. And within the IPCC, in that synthesis report, another figure I worked on showed that we have a set of enabling conditions, and we want more of these, but we also have to recognize constraining conditions that are holding us back. We want to reduce those. And central to this whole process is the idea that governments and civil society and the private sector need to be working together. So it's exciting to be here at FAPESP to think about how these things can come together, and we can be working on things like developing new innovation, financing the research and the development behind that. I'm very excited by this last bullet here, because this is one that is very important in the United States. It's one thing to suggest a green lifestyle or a lower carbon footprint, let's say. It's another thing when the infrastructure enables those decisions to be easier. So for example, if you want to buy an electric car, there need to be charging stations. If you want to reduce your carbon footprint in some way, it helps if there are celebrities and other kind of cultural icons talking about these issues and making it socially acceptable. And then of course, policy and other factors can support it. So I'm a big fan of making the right choice easy to actually do. And we need to help that happen. So to conclude here, in terms of major messages, when we look at the past and the present, we see that the current trends are incompatible with a sustainable and equitable world. Food systems remain vulnerable to climate risks, and we need better data and models to prepare for all of these threats. As we look to the future, we see that scientific advances have resulted in a better understanding of what the future will look like, and we really underscore how that future depends on the choices that we make today. We also see, when we look at our AgMIP results, that climate change projections indicate growing challenges and a strong emphasis on proactive and targeted adaptation and mitigation planning. And then finally, the extent to which current and future generations will experience a hotter and different world really depends on those choices that we make. And it's not some distant problem, it's the choices we make today and in the next decade. Our current agricultural models can help us start to enable and implement adaptation and mitigation actions, and we're looking for those solutions that are feasible, equitable, and just. So our choices are going to reverberate for hundreds, even thousands of years. And if you want to talk more about it, we'd love to have you come to our next meeting in Mexico. Thank you so much.
Eu dividir aqui bem sessões, fez uma início mostrando toda aquela articulação desse ser muito interessante, uma série de questões que podem surgir de todo esse desafio, né? Ele mostrou lá, ao invés dele na foto, ele estava no outro local tentando fazer uma articulação. Depois toda a parte de modelagem agrícola, né? Todo esse trabalho muito interessante aí do AgMIP. Na sequência, então, tem uma série de resultados. Naquela primeira parte, eu achei muito interessante aquele gráfico das idades, né? das faixas etárias, né? Porque acho que tem uma série de assuntos relacionados, né? Saúde, enfim, tem uma série de temas importantes aí com toda aquela questão da faixa etária. Depois a parte do sensoramento remoto, né? Muito interessante ali, todo o desenvolvimento, a quantidade de dados, acho que tem uma série de desafios. Depois a questão da complexidade da adaptação, né? Da bala de prata, lá que ele mencionou bastante, e finalmente aí o evento que acontecerá no próximo ano. Então vejo que nós temos 4 a 5 temas assim que são muito interessantes. Então vou abrir para perguntas, acho que eu vou deixar. Podemos, acho que, fazer umas 3 perguntas.
The questions are in English or in...
Português, porque ele está
Tá.
com... Então, fiquem à vontade. É mais uma facilidade aí da FAPESP, né? Destacar isso também.
Bom, então, parabéns pela palestra brilhante. E tem um ponto importante, é que os desafios estão colocados sobre a mesa. Como lidar com fake news, os movimentos anti-ciência que ocorrem no mundo todo em função desses desafios que precisam ser solucionados. Qual a sua perspectiva em relação a isso?
Acho que poderíamos colocar mais 1 ou 2 perguntas, assim ele já responde. Aqui, um colega nosso.
Olá, bom dia. Eu gostaria de saber um pouco sobre a sua opinião, principalmente quando você demonstrou que você estava em um outro local ali conversando com o pessoal que toma as decisões políticas e tudo mais. Como que você acredita que a comunidade científica pode estar mais integrada com as pessoas que realmente fazem as leis e conseguem fazer com que os impactos climáticos tenham soluções tanto na parte pública como a privada, como que a gente pode integrar melhor a comunidade científica mesmo com as ações? Porque eu acredito que hoje tem muita discussão, mas não tem tanta ação sendo tomada quanto deveria. Então, eu gostaria de saber isso.
Alguém mais quer fazer uma pergunta nesse assunto que o professor Márcio puxou, nosso colega aqui? Ah, não, colega nosso.
No mesmo sentido que o colega aqui colocou, como é que a gente faz para trazer a comunidade científica próxima das comunidades pobres, de quem recebe os impactos mais significativos do que todos os outros?
Até vou aproveitar aqui e colocar. O professor Márcio mencionou a questão do negacionismo, né? Porque assim, eu tenho percebido que hoje ele está bem disfarçado, né? As pessoas estão mais, vejo pela minha área, pela área agrícola, né? Está mais disfarçado. Então, conversando nós já percebemos, né? Não vem aquele discurso negacionista tão explícito, mas vem. E dentro do que o colega perguntou do governo, né? Eu sei que nós estamos agora numa eleição municipal aqui no Brasil, né? Que nós vemos nos municípios, né? Eu não acho que a campanha deve começar hoje, então não sei se alguém já viu alguma. Nós já tivemos alguns debates, mas eu não vi nenhuma menção ainda, um pouco que eu vi, questão climática. E os Estados Unidos está passando também por um processo eleitoral. Não sei se esse tema também está entrando, já entrou em discussão na eleição presidencial, que é importantíssima, né? A eleição americana sempre acaba sendo importante aí para o mundo todo. Então.
Taking on an order here, it's very challenging to deal with non-scientific approaches to these. There are groups that are certainly eager to keep things confusing, and when things are confusing, people cannot act. One of the things that we sort of recognize is that the fossil fuel industry has already priced in the profits from oil and gas and coal that has not yet been burned. So it's all of their share prices, their stock prices are already high in anticipation of burning them. So if we somehow make a suggestion that they won't be able to burn or sell those fuels, they don't see it as a lost future profit. They see it as a loss today. So there's definitely incentives that keep things confusing. But I do think in the grand scheme, in the last 20 or 30 years, the overall appreciation of climate change has grown dramatically, especially among the younger generations. And I think that has made it into policy. I personally love to talk to people about climate change. And in the United States, we have many people who still have big questions about it. I personally like to find out where they are stuck. And in some cases, they recognize that this is a very complex and challenging problem and that they are not an expert. So they rely on somebody else that they trust to tell them about it. And if that person is from a certain political perspective, they may have told them only some information. And it happens in both ways. I can't say it's only on the anti-climate change. You also get people who are very alarmist, who, again, are trusting other people. And I can at least understand that because it is a complex issue. There are other people who have a strongly religious standpoint that God would not let this happen, that humans are too small to make a difference. And if I understand that, I can speak in, I'm a religious person, I can speak in religious language and hopefully connect with them about specific things that you might find in religious texts, but also, you know, evidence that humans have affected society. I don't know if we have the pointer still, but I have a slide that would be great on this if I could get to the end. Yeah, let's see if it works. Yeah, like that. Okay, I have all these extra slides. These are the ones I didn't have time. Okay, here's the one I wanted to show. This is a river in Cleveland, Ohio, so in the United States, and the river caught on fire, right? If a river is on fire, something is wrong, right? So everybody understands that. And in this case, it was very easy because there was a chemical plant that was putting things in the river and that caught fire. So everybody could point their fingers at that chemical plant and say, they're the bad guy. For climate change, by the time you point the finger, you always end up realizing that all of us are part of the problem. You know, I came down here on an airplane. I don't pretend that I don't have a carbon footprint. So everybody is connected to this. And this is why that enabling conditions that I showed at the end are so important, that it really is we have to make the infrastructure easier for all of us to make better decisions. So I guess with the anti-science stuff, I would say if we make it easy for people to make the right decision, there will be less resistance. If we can understand influence and politics and some of those things, then we can address the questions more concretely. But then finally, if we put our trust in the information that we're providing, then people feel empowered rather than threatened. So that's often what I take. For the second question, in terms of how we can reach policy, in many cases, it's the same answer. Politicians are very concerned about their next election. They're very concerned about what they can declare as a victory and what might be considered a loss for them. So if they act today to prevent a threat in 40 years, they won't ever get credit for that. All they will see is that today things cost a little bit more. So it's a very big challenge. And in some level, that's why the IPCC is so valuable, is because we make the scientific case for them to make a policy decision which would otherwise be potentially unpopular. Now, I'm not saying that the science supports predetermined policy. If anything, the science very strictly is policy neutral. All we do is say this is the challenge that we see, and then the policies have to be shaped. But I'm more forgiving of the politicians because climate, as you saw in one of my charts, climate is only one of many things changing in the future. And I'm fully aware that there are parts of Brazil where farmers are struggling and looking for more agricultural lands on the margins of ecosystems. It's hard for me to tell that farmer that they can't feed their family, because me up in New York, you know, I am worried about climate change. So we have to make it so that there are alternatives. and allow the politicians space to recognize this big problem. But I would say reaching the policymakers requires long-term engagement, finding those policymakers who really know how to understand the science and think about the big picture, building coalitions so that the politicians are not on their own if they're making a hard decision. Those types of things go a long way. Now, reaching people who need the most help is very challenging, but that's why the civil society was such an important part of that circle I drew at the end, that it cannot just be the policymakers who may be connected to investors or political contributors or anything. This is a problem all around the world. So representing those civil society, those marginalized groups, which are almost always more vulnerable to climate change, is very, very important. And again, there has to be a recognition of this so that the people who are making those efforts get rewarded, at least in terms of popular support. And then, yes, to the final comment about politics, yeah, United States election right now is also very messy. And there is, I think, at least looking at the major political conventions, climate change was an issue at one, but not very prominent, and was pretty much absent at the other political party. And that's discouraging in the sense that we would hope that there would be a conversation about the facts and about the information, and then you can have that second conversation, difficult conversation about what do we do. But if we are still stuck on whether or not this is even a problem, then I feel like we are spinning our wheels. Now, again, we just passed the largest climate change investment bill in the United States that has ever been passed. There are new incentives for farmers to profit off of climate mitigation. And the farmer groups that I talk to are certainly more conservative and, in that sense, connected to the parties that are less worried about climate change. But farmers live their daily lives in the fields and they see climate change. And if you engage them on the facts and on the challenges and on the potential solutions and include them in that process, they will see that there is a lot to benefit and a lot to gain in their preparations.
Bom dia. Agradecer pelos dados que nos traz, porque todos estão baseados na ciência. E falando de segurança alimentar, eu gostaria de saber se deveríamos continuar produzindo alimentos da maneira que estamos acostumados, sobretudo pensando na produção de produtos animais. O que você acha, como deveria ser solucionado essa grande pegada de carbono? Tá? Muito obrigada.
Eu queria saber se ele tem caminhos, diretrizes ou sugestões para integrar esse conhecimento de modelagem em políticas de planejamento para adaptação, por exemplo, relacionados à infraestrutura crítica, preparação para desastres, etc.
Bom dia. Gostaria de saber que um dos... mais para aqui? Assim, obrigada. Teve um dos slides que mostrou que a gente já está num ponto de que não tem mais retorno. Tipo, daqui para frente só vai ser... Ou a gente vai escolher um caminho pior ou menos pior. Aí eu gostaria de saber em que ponto que a gente já chegou no final, que agora não tem mais retorno de voltar ao que era antes. O que aconteceu nisso que a gente se perdeu?
Eu gostei bastante da apresentação, acho que entendi, pelo menos razoavelmente bem, a parte de culturas de trigo, milho, soja, né? Quando você fala em sistema alimentar, você está falando basicamente do mercado de commodities, que é importante com toda certeza. Mas eu fico pensando aqui, por exemplo, a base da nossa alimentação, ela não é soja, milho e trigo, né? Quando a gente pensa em segurança alimentar, a gente está pensando aqui, no caso do Brasil, né, em arroz, feijão, mandioca, verduras, que estão nas mãos de pequenos produtores, né, que têm muito menos recurso financeiro, muito menos acesso a políticas ou estratégias ou a recursos de mitigação climática, e também trazem culturas que são menos resilientes, né? Se a gente pensar em brócolis, alface, que é a base da nossa alimentação. Então, eu queria entender se esse estudo que vocês têm feito, se essa modelagem, ela também chega no que a gente chama de base da nossa alimentação mesmo, né? Porque no futuro ali, se a gente tiver que, de repente, num extremo, escolher entre plantar soja e plantar feijão, talvez a gente não tenha muita escolha, né? Então, eu queria ter um pouco dessa perspectiva e entender se essa modelagem de vocês também chega para esse pequeno produtor ou para a produção do nosso alimento mesmo.
All right, I'll go ahead with that. Great questions. Yeah, very, very good to see. The first question was about, I understood it to be, can we continue to produce food the way it has been in the past? I think at some level, the idea that there has been one way of producing food forever is not exactly true, right? There's been constant innovation. The use of mechanical instruments, drones, and field observations, all of these things has led to constant innovation. And agriculture has actually been one of the most innovative fields around. I often joke that the closest I've ever been to feeling like I was in a NASA spaceship cockpit was being in an Iowa tractor and seeing 8 screens, and they're on the satellite to the radio, and it's amazing the technology that is in farmers' fields. But I think in terms of general, understanding that this part of the world produces this commodity, this crop, that might change. That there are places where certain crops are becoming more or less viable because of economics and climate and other things like that. So some of that is going to change. There are also very new innovative ways of producing food. There's vertical farming, energy intensive, city farming. There is the use of alternative proteins, whether it's plant-based things or lab-grown meats. There's talk of, strongly innovative things like using insect protein and other stuff like that to augment diets. So very exciting work on that, and a lot of high-tech investment in that area. I was recently at a meeting with Jeff Bezos, the Amazon founder. Now, he wasn't there, but his company, the Bezos Earth Fund, was there. And they are investing hundreds of millions of dollars in artificial intelligence for nature challenges. And climate, and especially alternative proteins, was one of their featured areas. But they had artificial animal-free cheese that was indistinguishable from real cheese. It was very, very good. They had samples and things like that. So it's really coming along quickly. So I think there's going to be a balance of that. I do worry that we will intensify some areas so strongly that they will lead to downstream impacts or degradation of some areas. There needs to be sustainability in our intensification. And I also worry that you can't grow all of your food in Brazil and the United States and China and then destroy the economies of many other parts of the world where, for example, in Cameroon, something like 70 or 80% of the economy is based in agriculture. So we have to think about the big picture. Now, in terms of how we integrate models, I don't know if I can still do this. Let's see how okay, too many things in that one. This is actually a graph of what that question was asking me about. This is a process that we've undertaken in many parts of the world where we actually begin by assessing the climate risks with the stakeholders, in this case, policymakers. And then we work with them to design pathways of agricultural improvement. And one of the first steps we ask is, what will the food systems and agricultural systems look like in 20 years or in 40 years? That is something we call agricultural pathways or representative agricultural pathways. Then we think about the adaptations that are proposed, and we evaluate those proposals and those systems under climate change. So this process, which weaves down, ends up with the evaluation of impacts under different policies, and then we circle back and we do it again. And we say, now that you've seen this, would you change your policy? Would you change your adaptation? And we iterate, we go around in circles with the policymakers so that they better understand how they can approach the policy and investment thing. So we've done that in many places, and we've started a little bit of this even in Brazil, but we would love to get it going again. Now, the question about whether we're at a point of no return and whether we can't go any farther, the world likes to draw very sharp lines, like 1.5 degrees or 2 degrees. And from a physical climate standpoint, those are not tipping points. It's not like just past that everything falls apart. 2 degrees is better than 2.1 degrees, and 2.1 is better than 2.2 degrees. So we want to keep it as low as we can. What we do see is that many systems start to fall apart above 1.5, and then even more so above 2 degrees. So those targets were drawn not because they are sharp lines, but because they are very clear milestones of where impacts are going to start to be more and more overwhelming. But I think that society is quite resilient, and that it really turns into the costs and the suffering that might encompass and might come along with those larger changes. The other thing that's important to note is that comment I made about the choices we make in the next decade. At the rate that we are burning fossil fuels and clearing land and other things that cause emissions, we will reach the total amount of emissions that reach 1.5 and 2 degrees within the next decade or so. So this is not a situation where we can sit around and say, we'll get to this soon. Every year that we wait, we use up more of our allocations, more of the greenhouse gases that are getting us to those places. So we are committing to future warming very quickly. What I'm worried about is that if you look in the last 20 or 30 years, the times when we have actually made international progress, the Kyoto Protocol, the Paris Accord, all of those, they tend to be times of surprisingly calm international crises. So it was kind of right after the Cold War ended, the Kyoto Protocol. After the economic crisis of 2008, there was a little bit of a settling period, the Paris Accord. With Ukraine, with war in Israel and Gaza, with all of these, economic crisis, with COVID, climate gets pushed down. And climate is often the third most important issue. Very big, top 3 issue, but not number 1 very often. And in that sense, it often gets pushed. So we need to keep it as something of focus. I really appreciated the question about commodities. Let me see if I have one more. Yeah, here we go. This is a project that we explicitly try to get beyond the cereal crops, because we agree with you that in terms of diet, there is a food basket that actually leads to people's diet. That includes beans, legumes, it includes root crops, fruits, vegetables, animal products. So this was a project that we worked on with the US State Department, and I know it's kind of complicated, but the website at the top, vax.theplotline.org, will tell you more about this. And you can see this is for groundnut or peanut. And we developed new crop species models for 20 species, including things like teff, fonio, Bombera groundnut, many more things that are not internationally traded, but very important. And we evaluated each of those crops for their climate change response, but also their nutritional content, including specific vitamins, folates, things like that. And then we also looked at their genetic data resources about have there been field trials and genetic testing, and also their biophysical resilience. So we were looking for those crops that are underutilized but have particularly strong adaptability to climate change. And you can see some of our projections there.
Bom dia. Eu tenho uma pergunta para o Dr. Ruane. Se ele fosse mais jovem... Bom, antes, eu vim aqui com meus colegas aqui de Botucatu, a convite do professor Ciro, e todos eles aqui presentes trabalham na linha de questão, na linha de segurança alimentar, indiretamente ou diretamente, com insumos alternativos, diminuindo as emissões de carbono, aumentando o estoque de carbono no solo. Então, sempre girando nessa linha aí. Então, como nós somos jovens pesquisadores aqui, eu queria saber do Dr. Ruane, se ele fosse jovem hoje num país tropical, numa agricultura que a gente tem aqui no Brasil, quais seriam os conselhos que ele daria para a gente, que está começando aí, que tem essa capacidade não de amenizar o problema, mas de mitigar os reflexos ambientais que a gente vai sofrer, segundo as pesquisas do Dr. Ruane. Obrigado.
Bom dia, tudo bem? A minha pergunta é em relação a como a NASA e o AgMIP tá pensando em colocar esses problemas na cultura popular e levar para fora da comunidade científica, porque se as fake news conseguem fazer com que as pessoas tenham algum tipo de ação, acho que as informações corretas também podem ajudar, assim, nesse sentido de conscientizar e fazer com que as pessoas consigam fazer as escolhas de uma maneira mais rápida, vamos dizer assim. E é isso.
Agradecer a apresentação e perguntar sobre a importância da diversidade do conhecimento local. Então, as populações indígenas, a gente sabe que elas cultivam uma variedade enorme de tipos de mandioca, por exemplo, ou, enfim, que é uma alternativa e faz parte da nossa alimentação aqui básica no Brasil. Nessa pesquisa que vocês fizeram com essas espécies alternativas na África, vocês levaram em conta essa variedade do saber local? Qual que é a importância desse saber local para os desafios que estão colocados para a alimentação? E, se possível, juntar também com essa pergunta que me antecedeu, no sentido de que talvez seja o caso da gente pensar em estratégias de conectar saberes diferentes, pensando nesse convencimento necessário, né, da população, incluindo os produtores.
Obrigado. A minha questão é um pouco diferente do tema que estão falando. A questão no Brasil de segurança alimentar está muito ligada às ineficiências ou ineficácia da logística. Uma tonelada de soja nos Estados Unidos chega no porto com um preço muito menor por causa do transporte e armazenamento e com quantidade bem maior. Quer dizer, no Brasil, há perdas enormes por causa de logística e custos enormes por causa de logística. E isso tem a ver, eu acho que isso deveria entrar na modelagem de ações que devem ser tomadas pelos governos para melhorar a segurança alimentar. Como que a logística, por exemplo, a logística na África, a logística no Brasil é completamente diferente de logística de outros países. Então, como que a logística entra na questão de modelagem de segurança alimentar?
All right, this is fun. Great questions. So I think in terms of the kind of new opportunities, there are lots, so I'm a little bit stuck on picking one here, but I would say that methodologically, the machine learning and artificial intelligence is a step change. It's a new world that I think is very, very exciting. The challenge that I've seen in it is that you are often having mathematical experts who don't understand the biophysical systems themselves. So you have math solutions that don't make sense or are not actually practically useful. So you need the combination of domain experts and mathematicians to make that work. And if you can find yourself somewhere in that equation, that can be very, very helpful. In terms of the areas, you mentioned some of them, tracking carbon storage pools and the actual exchanges and operation of different, even within plant nutrient pools is very important. Another area that I'm excited about right now is that many of the life cycle analysis, where you are trying to understand the total amount of greenhouse gases over the course of a field and a processing kind of pipeline, they often use standard coefficients and lookup tables to say what the impact of a certain management like tillage would be. We know that there is much more diversity across fields and across systems, and also that you may have a carbon benefit during a dry year and a loss during a wet year, or maybe it's the opposite. But that interaction across space, interaction across system, and interaction across year-to-year variability, I think is underappreciated. So I think that's one area. The other area that is always a problem in our projects are people who can really interface between the scientists and the policymakers. So if you are a very good science communicator, there is a huge need for people who can speak to both communities, and that's often very challenging because you have to track moving, dynamic kind of conversations in both places, but it's very valuable. That's at least a start for that. In terms of how do we introduce this topic for popular culture, you saw some of it, I hope, in my presentation. I talked about making t-shirts. I have my own website where you can put yourself in the chart. We have I have a group of interns right now working on a climate change video game, which is going to be played in classrooms and could be very fun, but again, very accessible, trying to get this out there. We have a strong relationship with the history and natural science museums in the United States. I happen to be only a few blocks away from the American Museum for Natural History, which is right near Central Park in New York. Beautiful place with many tourists, and we have a big climate change display there. You'll notice all of those beautiful animations that I had. Those were my science, but then NASA has an entire team called the Science Visualization Studio, which just makes beautiful movies and animations. And if I have good science, I can talk to them and they help me make good charts. So that kind of investment in the visual communication, and even this right here, this was, we worked with an outside group to make this, this product more accessible. So I think art and communication is really important, and scientific institutions need to support at least an infrastructure of communication. All right, the comments made about the indigenous and local knowledge are really important. This is something that we try to do. It's one of the reasons that AgMIP, I actually think the most lasting thing in AgMIP is the network of people, and we work with local scientists whenever possible. So for example, in this project, we had strong collaborators in Ghana and Zimbabwe and Senegal. And it makes much more sense for people to develop the crop models who are actually experienced in the region where that crop is grown. So, I don't think I knew what fonio was before this project, but it's an alternative kind of native grain in West Africa. So the people there who have the field experiments and can talk to the farmers, it makes much more sense for them to develop the models as well. But indigenous knowledge goes beyond that. It's also about adaptation approaches. It's about understanding selection of different systems. and how to deal with natural variability, and that needs to come into play as well. And I think this connects to the other question about how do we reach farmers. And in many cases, it's by using that diversity of knowledge and diversity of spokespeople who can say, from my perspective as a farmer, this is what I've seen. We have some farmers that I've worked with that are far ahead of their colleagues, and it helps when they tell their own story about how they are having a more sustainable farm, and the fact that it is actually making them a larger profit now. To hear that story from the farmer rather than from me is very, very important. I think the final question, I know we're getting short on time, the last question from this set at least was about the logistics and inefficiencies, at least as I understood it. This is why it's so important. I'm going to jump one more time. Let's see how far back I have to go to get to this. There we go. Yeah, this is why I like to include this chart, because what you were just talking about is in that social system and the transportation. There's a little orange box there that says transport. This is a major source of greenhouse gas emissions of how we transport food around, but also a huge area where there's food losses. And we often break up before the farm gate losses from pests and diseases and labor and things like that. And then after the farm gate, which is how food is lost as it moves throughout the system. And this also becomes an enabling condition. If we can build better infrastructure networks, that allows us to reduce those inefficiencies. And as far as I'm concerned, investment in that might actually be a stronger, per dollar, per real, solution than forcing the next adaptation into one field. So we have to think about all of these pieces together.
Muito obrigada pela palestra, as explicações. Achei sensacional. Eu dou aula sobre representações gráficas e isso aqui, para mim, é um parque de diversões. Eu acho que eu sou um ponto fora da curva aqui, eu sou veterinária, e vim aprender um pouquinho como a gente pode integrar isso nos nossos projetos, principalmente voltados para as doenças vector-borne disease. Então, se você tiver alguma coisa para indicar sobre os estudos, essas oportunidades e metas e objetivos voltados para o estudo das doenças transmitidas por vetores. Então, só para deixar isso, mostrar aqui para a gente, para eu poder buscar informação. Obrigada.
Olá, bom dia. Eu queria fazer uma conexão com o evento anterior do Miguel de Barros e como essas ações podem contribuir. É uma palavra que eu não escutei durante a apresentação. Ouvi no final equidade, mas justiça social, né? Porque desde os anos 80, aqui no Brasil, o debate do ambientalismo é muito ligado ao socioambientalismo, né? Justiça social, trabalho com as comunidades locais, indígenas, né? Prática de policultura agroflorestal na Amazônia, que é milenário. Eu gostaria de ouvir um pouco mais sobre isso.
Olá, bom dia. Queria parabenizar pela palestra, primeiramente, muito grata. A minha pergunta é sobre 1,5 grau. Eu trabalho com educação climática para educadores e sempre nas minhas palestras o pessoal fala, mas eu já ouvi na mídia que já ultrapassamos 2 graus, né? Porque tem muita confusão entre falar que o ano passado, né, foi 2 graus acima da média do ano anterior, enfim. Tem toda essa questão. Eu queria que o Ruane explicasse para a gente como que a gente sabe que a gente ainda não ultrapassou 1,5 grau, né, de acordo com os parâmetros do IPCC. Obrigada.
Eu sei que essa palestra vai ser muito assistida por estudantes. No nosso evento aqui da FAPESP, durante essa semana, aí já tinha ouvido isso. Os modeladores, as pessoas que trabalham com modelagem, dizem que nós, não sei se é um caso específico do Brasil ou mundial, nós temos uma roda de modeladores, pessoas que realmente desenvolvem modelagem. Né? Ele falou, nos oriente, que pode ser então, gostaria de colocar isso, porque eu sei que essa apresentação vai ser muito assistida, vai ficar lá na disposição, né? E as pessoas, às vezes, estão procurando ali uma área de trabalho. Eu queria ter feito a pergunta com o nosso diretor científico. De repente, ele abre um investimento específico, mas eu já ouvi isso, foi um pesquisador do INPE, o Gilvan, né? Isso acaba... eu já tinha ouvido isso de outros professores, né? Outras pessoas aqui, a professora Assunção, da USP, né? Eu acho que é algo relevante.
All right. Thanks for all the questions. I'm going to try to take them on one at a time. Yeah, exciting to hear about the livestock interests here. The vector-borne diseases are something that can affect animals and also plants. We have... I'm not going to go to the very beginning of my presentation, but if you remember, there was one diagram with all of the different teams. One of those teams was a pests and diseases team. We have some very good researchers, especially from France, who are working on this topic. For vector-borne diseases, there are several different things that you have to model. You need to model the vector itself. So if we're thinking of a grasshopper, where do the grasshoppers hatch? How do they move? Are they carried by the wind? Are they carried by their own jumping? Who knows what it might be? You can model that, but then once they actually land on a field, you can model the susceptibility of the field to the pest, and then the damage that they do to the crop. Every single crop species has a different relationship with each pest, and there are so many pests and diseases that it becomes almost impossible to develop a model for every single interaction. So instead, what often happens is the most prominent pests get some attention. And what we are doing right now in that AgMIP team is developing generic models that talk about how some pests eat the roots, some pests eat the stems, some pests eat the leaves, some pests will eat the grain itself. Some diseases block the leaves, they block the sunlight, or other things like that. You can classify them generically like that, and I think there's something like 12 different pathways by which pests and diseases affect plants. And if you make a model that can respond to those 12 pathways, then when a new pest arrives, you just classify each pathway and then you can go forward. So lots of research to be done, but that's one approach that we're taking, and very interesting to follow. And of course, I should say climate change affects the life cycles of pests and diseases in addition to their effect on the plants. In terms of the question about social justice, yeah, I had justice, I think, in my final slide, and as I was saying it, I thought to myself I should have talked more about it during the presentation, but it's very important, not just because it's ethically the right thing to do, but because a lasting solution needs to have justice as a component of this. So I think of climate mitigation and adaptation and sustainable development goals, including some justice elements. Right now, they're thought of as 3 different threads, but as we go further, they intertwine and they interweave and they become stronger because they are interwoven. And that is how we need to be thinking about it. It's a big challenge in some cases because development assistance or adaptation investment will feed into existing inequalities and reinforce and sometimes exacerbate those. A classic example is around gender issues, where women are often in many places doing the farm work, but the money is given to the men to control adaptation, and that can make things more challenging. So we need to think about how those things happen. We also have to think about the larger scale justice issues around historical emissions and ecosystem destruction and things like that. It is a stumbling block on the global negotiations, but there are more and more people thinking about how that will actually occur, whether it's through green funding mechanisms or other sources. So I would say that I'm not an expert in it, but I understand how important it all is. The 1.5 degree target and 2 degree target that I heard discussed, it's challenging because in the IPCC, we like to have at least 20 years before we will declare the climatological temperature. And last year was about 1.4 degrees above pre-industrial, but it's just 1 year. And it was connected to an El Nino and some other things that we know vary. But it's a sign that the world is warming and that there is this potential for more rapid shifts. I hate to do this, but if you think of natural variability like a wave with ups and downs, and then you add on top of it climate change, which is just going up, if you do both of those things at once, it looks like a stairway. Okay, that same wave going up looks like a stairway. I think what actually happened last year is that we were on one of those upstairs because the El Nino replaced a La Nina, and the global warming that had been occurring but was being hidden by that La Nina, all of it basically came out at once. So we've seen this a couple times, and I think it will continue happening. And the question is it going to come down, or is this the new normal as we get ready for the next step? But it's hard to say because we need 10, 20, 30 years before we can be certain on a climatological way. But that said, we are not in a position to always have statistical certainty before we take action, because we know that waiting for that certainty is going to lose time that we need for adaptation planning. So we are in a situation of changing baselines and need for proactive action. And then finally, to Jurandir's question here about model developers, I should have mentioned this also as a huge opportunity for young people. Crop modeling has the unique ability to go beyond the observed system. It helps us understand the data we have, and it helps us anticipate different systems, different opportunities, and different risks. There are many huge questions in crop models. I would call out multi-cropping, intercropping, pest and livestock interactions. Those types of things are not very well understood. It's a challenge because if you ask me if the models are ready today to do everything that we want, I would say no. But the potential of models to answer the questions is unmistakable. We need to be able to develop those models. And I would compare it to early stages of weather forecasting, where you might not trust the weather forecast models, but we knew at that time that we needed to make the models better because there was the potential to do better. And as somebody who knows TV meteorologists who stand up and make the forecast, remember that we used to all complain about today's forecast. And now we are often complaining about the 3-day or the 5-day forecast. Things have gotten much, much better, even as we still complain that our meteorologists aren't good enough.
Bom, então eu quero agradecer novamente, né, inicialmente o professor Ruane pela presença, a NASA, né, instituição de origem dele, a todos os presentes. Acho que é muito bom, né? Acho que a palestra foi excelente, a participação de todos foi muito boa. Então, por isso que acho que o evento foi muito bem sucedido. E falando dos presentes, né? Aproveito, como eu disse, esse vídeo vai ser muito consultado. A FAPESP, né? O professor Márcio apresentou os próximos eventos, professor Jolie, professor Esther e outros organizadores. Então, quem estiver assistindo, né, venha presencialmente, né, tem oportunidade aí da tradução simultânea e também de interagir com grandes pesquisadores, como foi o caso de hoje, né. Agradeço aí a FAPESP, professor Márcio, professor Zago, professor Jolie, professor Esther, toda a equipe aqui que está no suporte, no apoio, as tradutoras, né, a gente sempre esquece, um trabalho importantíssimo, a Vera aqui da FAPESP. Então, são os principais. E também quem estiver depois nos assistindo aí pelo vídeo, sem dúvida será um material de consulta e pesquisa muito importante aí para os vários níveis acadêmicos, né? O professor conseguiu colocar assim num nível muito bom. Acho que nós teremos aí um número de consultas e pesquisas muito grande. Então, vou passar aqui para o professor Jolie.
Bom, em primeiro lugar, gostaria de agradecer ao professor Ruane pela excelente palestra. pela qualidade do material que ele trouxe nos seus diapositivos, como o Jurandir já mencionou, elaborado de tal forma que é um assunto interessante para nós que trabalhamos com esse assunto aqui, mas também está numa linguagem que pode ser utilizado nas escolas de ensino fundamental e médio. A organização desses ciclos de palestra, que é uma iniciativa que começou quando a FAPESP fez 60 anos, há 2 anos atrás, ele é bastante complexo. A professora Esther aqui acompanha isso. O professor Ruane foi convidado com mais de 1 ano de antecedência, porque realmente para a gente trazer profissionais dessa qualidade, a gente precisa ter um convite, uma definição com bastante antecedência, e isso dá, às vezes, muito trabalho. E assim eu volto a repetir que sempre na última sexta-feira do mês, no período da manhã, a gente tem essas palestras do ciclo. As próximas 3, então, no dia 27 de setembro, repensando a pós-memória. Nós vamos entrar em 2 palestras que são mais da área social e de humanidades. No dia 25 de outubro, Latim em Pó, que a nossa língua pode nos ensinar sobre democracia. E dia 29 de novembro, o futuro dos combustíveis para a mobilidade. Então, eu espero contar com a presença de vocês aqui. Agradeço novamente ao professor Ruane, ao professor Jurandir pela mediação e à FAPESP por nos acolher aqui. Muito obrigado, um ótimo final de dia para todos.